So in this video, continuing with binomial probability, we'll be focusing on using worded questions and how to translate them into more standard probability notation, and also focusing on how you should be setting your work out with binomial probability questions in exams, particularly if you are using a calculator. Now, one of the biggest challenges when students are working with binomial probability is the fact that they struggle to understand or convert a worded question into more textbook basic notation questions. So it's really important that you understand and practice understanding and working with worded problems to make you more confident and comfortable in working with exam style questions. Now, when starting any binomial probability question, it is vital that you always start by writing the parameter. And again, if you look through examiners' reports of mark schemes or exams, I should say, that generally a lot of students tend to forget that they never start by writing the parameter. So it's always important that you start every single question. Now, you don't need to do this for every subpart of a question, but as long as you start just before you start part A, let's say, that you identify X is being binomially distributed with N and the probability of success. Now, obviously, if that does change halfway through a question, so another variable is introduced, then you probably need to set the parameters again. But this is worth actually 1 mark of just writing this if you look at general mark schemes for the latest exams. Now, as in exams, most questions will be worded, so it is really important that you're able to read what it is you're actually trying to find the probability of. So, for example, if you've got a worded question, you want to kind of convert it to one of these couple of things. So whether you're looking for X is less or equal to a value, where X is less than a value, where X is greater or equal to a value, where X is just greater than a value, or if X is between two values, inclusive and exclusive of those values. So the next thing we move on to is being able to translate this. Now, obviously, these are really good to have in your notes, particularly if you're starting out with binomial probability and things aren't quite making much sense, and where you can just substitute the numbers in. Now, generally speaking, when you're dealing with when n is small, then you can work out each individual probabilities, and depending on how quick and confident you are using your calculator, you could come up with a question in the same way. But it's also, to do well in maths, it's about 65% knowledge, 35% common sense. So if you could try and be smart about the questions or manipulate the questions, you might find you becoming a little bit more efficient and a little bit quicker, particularly with more long-winded questions. Now, the method you can see on the screen is, generally speaking, another way of thinking of rather than looking at individual probabilities, but also when n is a large number. So for example, if n was, like, say 120, and you had to find the values of where x is less or equal to 43, you don't really want to be working out 44 different probabilities and adding them together. So you want to kind of be smart about this. And you might be also thinking there's that type of question, although albeit all possible, is going to take you absolutely ages. So obviously they're going to encourage you to use a calculator. Using a calculator is not cheating, the examiners know, but just bear in mind that when a question is kind of prompting you to use a calculator, that the marks for that question are going to be considerably low, whereas if you were to use a more analytical way of writing things down, then a question might be worth several marks. So I would recommend that you pause the video, have a note of these, and then what we'll try and do is we'll swap the A's, B's and N's and P's for values, and then we'll see how this all works. Now again, like I said, the key important thing is that we tend to use this method when n is large, but like I said, it's all about just giving you another way of working certain questions out. So let's have a look at some examples. So whenever you're starting a particular question, so here we've got the parameter of that x is binomially distributed with a sample size of 10 and the probability of success being 0.4. Now, I've purposely picked something that's relatively small, and when n is small, what I strongly recommend, especially when you're still starting out and you're not quite making much sense, I would start by writing the numbers out. So all the numbers, including 0, which is a number that a lot of students tend to forget. And to try and get an understanding of what it is you're actually trying to find and what the question is actually asking you to find. So if we just quickly, and I should have numbered these before, so let's just number them now. So 1, 2, 3, 4, 5, 6, 7. There we go. So what I'm going to do is I'm going to substitute the letters with the numbers. So if you're working with x equals a number, then it's just a case of straight put it into the formula, job done. So here our n is going to be 10 and our a is going to be 5. Our p is going to be 0.4 to the power of how many successes we want, which is 5, and this is going to be 0.6, and this is going to be 5. Like so, we bung that straight into our calculator, job done. Now, when we start working with questions involving inequalities, now like I said, if n is relatively small, I strongly recommend you write the numbers out to gain an understanding of what it is you're actually trying to find. So here we're looking for, in number 2, we're looking for values of x where it's less or equal to 4. So what I'm wanting is a different colour pen. And so from this, I am wanting these 4 probabilities. Now obviously, to work this out now, obviously if a in this case is small, then I could work out each individual probability, or what I could do is just simply, again, if you've watched a video on how to use a calculator, now how to use a calculator, I can put that straight into my BCD form and get the answer straight away. Now when it starts working with question 3, so this is for values of where x is less than 3, so I'm wanting values that are basically 2, 1 or 0, and again I could work out individual probabilities, or I could work out the probabilities of where, so this one is also probability where x is less or equal to 2. So although the numbers in the question are different, they both can give me the same sort of answer, but one's using a different inequality, hence why it's different. Now with question 4, I'm wanting values that are greater or equal to 6, so inclusive of 6. So the numbers I'm wanting are these ones here I'm highlighting in red. Now the probability of adding those 5 numbers should be the same as working out what I don't want and taking away from 1. So this is the kind of thinking you want to look at, is basically there's 2 ways of working out a probability question. You can either work out the probability of what you want, or you can work out the probability of what you don't want and take it away from 1. And one of the reasons why we can do that is because there's only 2 possible outcomes, and it's either success or a failure, and that's why it works. So then moving on to question 5, so here we're looking at values that are greater than 7, so then that's going to be including, so again it's worth writing down what numbers are we actually looking for. I want the probability of 8 is fine, 9 is fine, and 10 is fine. Don't know what that is there. So again I'm looking for these numbers, or I work out the probability of where x of the numbers I don't want and take it away from 0. Now when you start moving on to ones with double inequalities or double-sided inequalities, like we have in question 6, so here I'm wanting numbers of 3 to 5 inclusive of those numbers, so I'm wanting these 3 numbers. Now one way of doing that is, obviously I could work out the 3 individual probabilities, but another way of working this out is the probability of x is less or equal to 5, which is going to give me these numbers, minus the probability where x is less or equal to 2. So I could actually work out those 2 probabilities and then take it away from each other. And again, you want to kind of be a little bit smart, and you might find that in part A or part B of a question you've actually worked out one of these probabilities, so the examiners or questions that you're doing in a textbook are prompting you to use previous answers, obviously on the condition that you've got them right. So for question 7, here we're looking at probability of numbers between 4 and 8 inclusive of 4. So I'm wanting 4, 5, 6 and 7. So again, I could work out those 4 individual probabilities if there's not that many, or I could be able to try and be a little bit smart. So again, it's the probability of x being less or equal to 7 minus the numbers that I don't want, which is a probability that x is less or equal to 3. And likewise, so these are the kind of methods that you want to kind of think of, and particularly when you watch the video on using a calculator, working out these types of probabilities and less or equal to values are definitely going to come in handy, because your calculator will instantly work it out for you, rather than you typing working out every individual value of x that falls into that inequality. Now one thing to add is, if you are going to use your calculator, it is really important that you show as much working out as possible, particularly in your methodology of what you're actually typing in. Now typically on a calculator paper, teachers would recommend that you always write down what you're typing in on your calculator, but with probability questions, if a question is worth 3 marks, you're not going to get 3 marks simply by typing numbers into your calculator and writing down one number. you have to show the methodology of what you actually worked out. So one thing I would strongly recommend is that if you are going to prominently use your calculator to work out binomial probability questions, which you're completely and utterly entitled to do, I strongly urge you to write down what your methodology or what your thinking is before you enter values in. And what I mean by that is writing this down at the very least in your solutions, and then obviously swapping A's, B's and P's with the actual numbers, and then writing out. And if you get chance at the end of the exam and you find as if you've got 5 or 10 minutes left, or you've exhausted all the things you can do in all your previous questions, go back and add working out to your answers, because, and like I said, it's a good way of not only maximising marks, but it's a really good forceful way of checking to make sure you've not made any silly mistakes which could cost you, particularly with big mark questions.